Good morning, students. I am Dr. Vijay Bandari, Associate Professor from SIRTS CSE Department. So now let's start experiment number 9. We are going to perform today experiment number 9. The name of the program is Implementations of Thompson Sampling Reinforcement Learning using Python. So before this, we are going to implement this. I will tell you about Thompson sampling. Okay, so let's start with the Thompson sampling. The reinforcement learning is a branch of machine learning, also called online learning. It is used to decide what action to take at t+1 based on data to time. This concept is used in artificial intelligence applications such as walking. A popular example of reinforcement learning is a chess engine. Here the agent decides upon a series of moves depending on the state of the board, means the environment, and the reward can be defined as win or lose at the end of the game. So now Thompson sampling is sometimes it is called probability matching. It is an algorithm for choosing the actions that address the explorations and exploitations dilemma in multi-armed bandit problems. Actions are performed several times and it is called explorations. It uses training informations that evaluates the actions taken rather than re-instructs by giving correct actions. This is what creates the need for active explorations for an explicit trial and error search for good behavior. Now, based on the results of those actions, reward and penalties, it indicates by 0 and what is indicating by 1 are given for that actions to the machine. Further actions are performed in order to maximize the reward that may improve future in performance. Now we suppose a robot has to pick several cans and put in a container. Each time it put the can to the container, it will memorize the steps followed and train itself to perform the task with better speed and precision reward. If the robot is not able to put the can in the container, it will not memorize that procedures. So that's why speed and performance will not improve. Now this time it will be considered as a penalty. So Thompson sampling has an advantages of tendency to decrease the search as we get more and more informations, which mimics the desirable trade-off in the problem, where we want as much information as possible in fewer searches. That's why this algorithm has a tendency to be more search-oriented when we have desirable trade-offs in the problem, where we want as much information as possible in fewer searchables. Hence, this algorithm has a tendency to be more search-oriented, and when we have fewer data and less search-oriented when we have a lot of data. So now we will talk about some practical applications of Thompson sampling. We can use in Netflix item-based recommender systems. What is a Netflix item-based recommender systems? Images related to movies and shows are shown to users in such a way that they are more likely to watch it. Second is that bidding and stock exchange, sometimes predicting stocks based on current data of stock prices. And third is traffic light control, sometimes predicting the delayed in signals. And fourth is automation in industries. Boats and machines are transporting and delivering items without human intervention. Now we see the practical of Thompson's sampling, and now implementing this using Python. So now let's start Sublime. This is the very lightweight editor. Now we first importing the libraries. into first cell importing numpy as np and matplot and pandas. Now importing the data set into second cell, data set is equal to pd.read underscore csv. We are taking ads of optimization dot csv. This is the data sets you can see here, and this is the data set which we have downloaded from the UCI machine learning. You can also download it, and these you can see ads 1, ad 2, ad 3 up to 10. Okay, now here we applying the Thompson sampling techniques. So now we are importing randomly and is equal to 10,000 and is equal to 10 and add selector. So these methods are we are applying, and plotting histograms, ad selected, histogram of the ad selection in the x-axis and number of times each ads was selected in y-levels. Now plt.show is using for the showing the plot. Now we run this code and getting the results. This is the histograms of ad selection in the x-axis and y-axis number of times each ad was selected. So this is the Thompson sampling. You can see here we are maximizing the ads, increasing the each of number of times each ad was selected. So these are the ads, and number of each times ad was selected. Okay. Now this is also the figure 1 histogram of ad selections. This particularly plt.show and plt.hist, it is actually showing the ad selected, okay, and according to a histogram of ad selection. So it might be clear to all. If any doubts, so you can ask me. Thank you. This is the sampling theorems. Thanks. Thanks. Whatever.